Good afternoon, everyone. Hi, I hope all of you are doing fine. Okay, so in our last session, we had studied about the introduction to squares, right? Then methods to find the square of a number. The first one was by multiplying a number by itself, and the second one was the splitting method, right? Okay, so what's the plan of today? Yes, so today we are here to study the properties of square numbers. So let's begin with the properties. Numbers ending with the first property states that numbers ending with 0, 1, 4, 5, 6, or 9 and unit places are perfect squares. What does it mean? So if I take a number 289, right? So it ends with 9 in its units place or its ones place you say, right? This is a ones place, right? So it ends with 9. So is it a perfect square? Yes, so this is a perfect square. Why? Because it ends with 9 units in its place. See? But, but, do all the square numbers, all the numbers that end with 9 at the unit place, are they squares? 89. Is it a square? No. So this is not always satisfied, okay? But if you can assume that 0, 1, 4, 5 or 6, 9. It's C. If here you notice C, they're always ending with 4, 9, 6, 5. Again 6, 9, 4, 1. Right? 1, 4, 9, 6, 5. Right? So every time you see they are ending with 0, 1, 4, 5, 6, or 9. Right? That's right. This was a problem. The second thing is numbers that end with 2, 3, 7, 8 are not perfect squares. They're obviously not perfect square. Obviously, okay. Any number you take 78. Is it a perfect square? No. This is not a perfect square. The third, so second property also is done. The third property says that the square of an even number is always an even number and the square of an odd number. Okay, so your even number, any even number can you think of? Whose square we can find? 12. Is it an even number? Yes. So when we do 12 square, it is 144. So this is also even. Yes, even. So square of even number is always even and the square of an odd number is always odd. Odd number if I have to take, then I will take 13. What's the square of it? 169. Right? So 169, is it an odd number? Yes, it's odd number. So the square of even number is even and the square of an odd number is odd. What's the next thing? Okay, next. The number of zeros at the end of a perfect square is always the double the number of zeros at the end of the number. Which means if you have to find the square of 10 square, so its square will have two zeros, double, right? So what's the double of 1 0? 2 zeros, right? So its square will be 100. See, if here 1 0, here 2 zeros. If here it's 100, then what will be over here? It will be 10,000. Double. Okay. It says that the number of zeros at the end of a perfect square, the number of zeros at the end of a perfect square is always double the number of zeros at the end of the number. So how many zeros are there? It's double in its square. Okay, so if we take a number now, 130, not 260, 130. So 130 square, if we have to find, then what will be the answer? Here you see it's only 1 0. So double of 1, it will be 2 zeros and its end. And 13 is 169. Right. So this will be your perfect square. Understood? This is the rule. Next. Square numbers can only have even number of zeros at end. Yes. So number of zeros at the end is always even. Square numbers are always even numbers. Now 260 0, 0. This is not a perfect square. Now the reason why it's not a perfect square, it's a very simple reason. Because you see, there are 3 zeros. A perfect square can never have 3 zeros. Because it's odd number, right? It will always have even number of zeros at it. See? Now, if we see over here, yes, see, yeah, in the square of 420, it's 2 zeros, even number of zeros. In the square of 10, also in the same way. Next. This is also clear, I think, right? Next, there are two n non-perfect square numbers between the square of two consecutive natural numbers n and n plus 1. So what do we mean by consecutive? It's next to next. So consecutive number of 2, it's 3. Of 4, it's 5. So consecutive numbers. There are two n non-perfect square numbers. 2n, that means where if n is equal to 2, if we take n is equal to 2, so n plus 1 will be equal to 3. So between these two squares of this number, not between these two numbers, squares of these two numbers, we will find 2n perfect squares. 2n in the sense 2 into 2 is equal to 4 perfect squares you will find between 2 and 3. You want to check? Let's see how. Now I have to find the number of perfect squares between 3 and 4 square, right? Between the squares. So 3 square is 9, 4 square is 16. You have to count 10, 11, 12. No need. For beginners, what we'll do? Directly, this is n and this is n plus 1. So what will you do in this case? You will multiply 3 2 times. Don't multiply 3 square times. You will multiply 3 2 times. It will be 6. So there are total 6 square numbers between 3 square and 4 square. Is it clear? Okay. So next thing. What's the next property? So I think you are clear with these properties. So let's move on to the next property. The next property states that if a number has 1 or 9 in a unit's place, then its square ends in 1. What does it mean? See, if a number, any number, you say, I'm taking now 19. Okay, so if a number has 1 or 9 in its unit place, so what is the unit place? 9. Then its square ends in 1. Your square will end in 1. What's the square of 19? 361. See, the units place of your square will be 1. Why? You might be, a question might strike your mind that why is it so? It's because 9 nines are 81 and 1 over here is it's at the units place, right? So while multiplying 19 into 19, we'll of course get 1 is the answer in its units place. See, if I will have to show you the table. See, where do we find 1 in the units place? In the square of 1, in the square of 9, the square of 19, and the square of 11. Where there is 1 in the unit, when a 9 in the units place, 1 and 9, there we find the answer to be 1 because 1 ones are 1 and 9 nines are 81. So in both the cases, 1 into 1 is equal to 1, 9 into 9 is equal to 81. Both the cases we are getting 1 in the units place. So when we do the square of any number with 1 or 9 in its place, then its square will be 1. Okay, next thing. When a square number ends in 6, the number whose square it is will have 4 or 6 in it. That means if a number, 16, if you are going to find the 16 square, so what it says, 6 is a 36. Am I right? 6 6 are 36. And 4 4s are how much? 16. So both are having 6 in their units place, right? In the ones place, they are having 6. So if any number is going to end with 6 in their units place, then the answer over here will be 6 in their units place also. If it's 4 14 square, it is 196. See, 6 in it. It is going to be very helpful when you're going to study long division, estimating, and all sorts of things. Okay, so it's very useful. Understood? Next. If a number has 5 in the units place, then its square ends in 5. Why? Because 5 into 5 is equal to 25. That's why. Let's check it if it's true or not. If we have to get the square of 25, it's 625. And the unit space is 5. Over here also unit space 5, over here also. And if this case comes with 0, if a number has 0 in the unit space, then its square ends in 0. The simple reason is 0 into 0 is equal to 0. So if I go 20 into 20, that's why it's going to come 400 and with 0 in its units place. The next property states that if a number has 2 or 8 in the units place, then its square ends in 4. If it has 2 or 8, if we have to find the square of 18 and 12, so they have the units place 2 and 8. So what will be their units place and their squares? It will be 4. Why? Because 8 8s are 64, 4 over here also, 2 2s are 4, 4 over here also. That's why. Okay, I hope this is also clear. 2 or 8 in the units place, then its square will end in 4. 3 or 7, it will be 9. Why? Because 3 3s are 9 and 7 7s are 49. So both are going to have 9 in their units place. So that's why if I'm going to take 23 square, then its units place will be 9 because 3 3s are 9. And if it's going to have 27 square, then also the ones place will be 9. Right? Okay. So this is the property. If n is a perfect square, then 2n can never be a perfect square. That means, let's take n. N is equal to 5. Okay. So 5. Then if n is equal to a number, if n is a perfect square, if n is a perfect, sorry, not 5. We cannot take 5. Okay, so if we'll have to take a perfect square, think of a perfect square, 9. So 9 is a perfect square, 3 square. Yes, so if nv is equal to 9, then 2n can never be a perfect square. 2 into n is what? Now, 2 into 9, it's 18. 18 is not a perfect square. It says that anything you take, anything, if 4 is a perfect square, 2 2s are 4, but 4 into 2, 2n, which becomes, if n is equal to 4, then 2n, 8, will never be a perfect square. It means that, like if any perfect square, okay, 16. Is 16 a perfect square? Yes, 4 4s are 16. So if we are going to consider n is equal to 16, then 2n will be equal to 2 into 16 is equal to 32. 32 is not a perfect square. Okay, it's a very simple thing. If n is a perfect square, then 2n, that is 2 multiplied by the number, the perfect square, is not a perfect square. It's never. Okay. So let's solve few questions related to it so that we become more clear with the properties of square number. Next, first question asks us that what will be the unit digit of the squares of the following numbers. So they're only asking about the units digit. Okay, what will be the units digit? So the first thing, if we take 81 square, so what will be its units digit? 1 ones are 1, right? 1 ones are 1. So what will be there? Any number that ends with 1 or 9 in its units place, that number square will be 1. So their units place will be 1. What about the second number, 272? Any number that ends with 2 or 8 in its units place, it's going to have 4 in its units. If you are not able to remember these things, it's not important to remember also. You can just simply check when you're going to multiply the units place. 2 2s are going to be 4. So the units place will be 4. 1 ones are 1. It's going to be 1. 9 9s are 81. So 81 has 1, right? In its units place, so it will be 1. You don't need to remind that if 2 or 8 is there, it will be 4. If 3 or 7 is there, it will be 9. No, it's not that important. You can multiply also and check. Then 799 square. What about 799 square? 9 and 81. So 81. Here 1 is there. So here also 1 in its units. Okay, fine. Let's go to second question. The following numbers are obviously not perfect squares. Give reason. Oh, it's mentioned like these numbers which are given, they are not perfect squares. But why do they say with so much of confidence? Let's see what they mean. 7, 3, 8, 2, 0. So if you notice in the first 4 numbers, the numbers are ending with 2, 3, 7, and 8. As I had taught you in the properties of squares, that if the numbers end with 2, 3, 7, 8, they are obviously not perfect squares. I meant that it is possible here if I say that 9, they are units place, they are perfect squares. It's it's not, it's mostly, it's maximum, if you see, that's possible, but 89, it's not a perfect square, still it's, but 2 3 7 8, it's obviously not. This is true, it has no options. If the number is going to end with 2 3 7 8, then of course it is not going to be a perfect square. So because, what will be the reason? Because 1 to 4 end with the digits 2, 3, 7, 8. First reason. Now there are 0. 0, if it ends, it's a perfect square. But you see, I had told you that there will be even number of zeros in a perfect square. But over here, there are odd numbers of zeros. There are 3 zeros. 3 zeros, right? So it's not possible. So the second reason, because in fifth sum, there are odd number of zeros. Odd number of zeros are never present in a perfect square. Let's see what's next. Find the number of non-perfect square numbers between 14 square and 15 square. Yes, so this is the question. Yes, between 14 square and 15 square. I had told you. Now 14 square, it's 169. Sorry, 196. 196 and 15 square is 225. So if we are going to again count or subtract, no, that's not the method I told you. If there are two consecutive, 14 and 15 are consecutive numbers, right? Aren't they consecutive? Consecutive in the sense they are next to next, right? Like 3, 4, 5, 6, 7, 8, and 10, like that. 14 and 15 are consecutive, right? So if we can say if n is equal to 14, then n plus 1 will be 15. What is the method? 2n. That means 14 into 2. What will be the answer? 28. So there are 28 non-perfect squares between 14 square and 15 square. So between two consecutive squares, there are 2n. 2n, where n is the number, right? One number. So n is the number, where 1 is n and the other is n plus 1. Non-perfect. Non-perfect, not perfect. Between 14 and 15 square, you won't find any perfect square number. Okay, so I hope you enjoyed till here, right? If you please don't, if you please write in the comments box if you have any doubts or you have not understood any particular topic. You want me to re-explain it to you all, or you while solving few sums you come up with any doubt. Kindly send in the comments box below, comments box, and I will try solving it. Okay, and I'll let you know. Thank you.